Data can be represented in a way that is intended to sway an audience one direction or another. And there are some common ways that graphs can be manipulated. One way is by omitting the baseline. By omitting the baseline, this makes the changes look larger than what they could be. So in our example, our baseline starts at 50 instead of 0. By doing this, group A looks much larger than groups B or C. If we start the axis at 0, we get a more accurate depiction of the differences between our bars. Another way is by manipulating the y-axis. So by extending the y-axis further than what is needed, it can make it look like it's a small change over time. If we work on our y-axis so that our data fills the graph more appropriately, then we get a better idea of how the change looks over time. Cherry-picking data is another way that the graphs can be manipulated to try and portray a certain trend. So if we only pick a few months out of the data that we have, it can look like the trend is upward. Where if we depict all of the data that was collected, we might see a different trend. Using the wrong type of graph is another way that can be used to manipulate data. If we look on the left-hand side, we notice that they're using a pie chart. This is misleading because the pie chart does not add up to 100%. Pie charts are much more appropriate using numbers that give you 100%. A bar graph is much better to depict the data that is represented here. Another way to manipulate and bias people is to go against common conventions. So common conventions, looking at this graph on the left-hand side, you would think that a more densely populated area would be a darker shade. By flipping this around and making the more densely populated area lighter, it makes the graph misleading. However, if we look on the right-hand side and the population density is darker, this gives us a more accurate way of looking at the data. What manipulation is being used in the data provided in these two graphs? The one on the right has the baseline omitted. The one on the left shows the baseline. Both of these are identical presentations of the data, but the one on the right shows that it appears that there is a larger change in the weekly allowance. If you were a parent, you would choose the one on the right. If you were a child wanting to increase your allowance, you'd probably pick the graph on the left to show the information that you wanted. What manipulation is being used here? Well, this is a manipulation of the y-axis. By stretching out the y-axis above the value where our data is, it looks as if the average temperature has not changed. This graph is also missing units on our axis. By adjusting the axis so that it is not so far above the data, then becomes easier to see the change in temperature. What manipulation is being used in this graphic? This would be cherry picking data. If we look closely, it says that it is support for President Trump's job approval by Republicans. By not presenting all population, this makes the approval rating probably seem higher than it is. I'm not trying to influence anybody's politics. This was just a good example of cherry-picking data. By looking at Democrats, Independents, and Republicans, we might come to a different conclusion in the approval rating. What manipulation is being used in this graph? Well, it is the wrong type of chart, wrong type of graph. Because it doesn't add up to 100%, this would much better be represented by a bar graph. By looking at it as a bar graph, it shows much better understanding of the players drafted by the different schools. What manipulation is being used here? This is going against conventions. The y-axis is upside down. It actually starts at 0 and increases towards the bottom. So to look at this graph appropriately, we actually have to flip it around. And so we see that once the legislation was introduced, the gun deaths actually increased. What manipulation is going here? This one's a little tougher. Might take you a little bit to find what's wrong with this graph. The x-axis points are inconsistent. So they're trying to show a linear relationship, but the distance between the points is not the same. And so this is manipulating the x-axis. What is the difference between causation and correlation? Well, causation means that one variable directly causes another to happen. Like, I stubbed my toe and now my toe hurts. Me stubbing my toe caused my toe to hurt. Correlation is just when two variables change together. A cause is a condition where an effect occurs. An effect is the difference between what happened and what would have happened if the cause was not present. So, in order for there to be an effect, there has to be a cause. Now, causation and correlation are not the same thing. In order to determine causation and not just correlation, we have to satisfy three criteria. First, we have to know that X comes before Y. So we have to know the cause happens before the effect. Number two, X must covary with Y. Y is more likely to happen when X is present. The hardest criteria to satisfy is that X and Y are free from confounding. So confounding is much harder to prove, and it means that nothing else can cause Y. Because of these three criteria, correlation is much more frequent than causation. Let's look at an example. If a match is lit, it causes a forest fire. Okay. Well, does A precede B? Yes, if a match is lit, it comes before the forest fire. Does A covary with B? Yes, a forest fire is more likely if a lit match is present. Is it confounding? Is it free from confounding? We would need more evidence to show that the lit match caused the forest fire. There are other things that could potentially have caused it, like lightning or a stray cigarette. How about high grades in high school cause better health in adulthood? Well, high school does precede adulthood, so A precedes B. There are studies that show that A co-varies with B, so it's more likely to have better health if you have high grades in high school. But is it confounding? Is it free from confounding? A does not necessarily, so high grades in high school do not necessarily cause better health, but it could be related. More sources are needed. It is not free from confounding. Do Japanese passenger cars being sold in the US cause a higher incidence of suicides by crashing a motor vehicle? Well, let's use our three criteria. Do the sales of Japanese cars happen before the crashes by suicide? It's a little difficult to tell. They kind of vary together, kind of trend together, but it's difficult to tell if one happens before the other. Does A co-vary with B? Well, there's similar trends, and we can see that by the graph. Is the relationship free from confounding? No, we cannot say that suicides by crashing motor vehicles is caused by the sale of Japanese cars. If you're unsure if it is causation or correlation, it is more likely to be correlation. Causation is much more difficult to prove. Hopefully, through this chapter, you have learned about how to make proper measurements to the proper number of decimal places and report the uncertainty. You've learned how to use scientific notation to write large and small numbers. You can use dimensional analysis to convert between units. Learned about how the metric system works and how we can use the metric system. Know what makes a good graph and how graphs can be manipulated, and also learn the difference between causation and correlation.